Hello? Okay. Hello, everyone. Thanks for showing up, joining my topic here. And I would like to start a bit early in order to save more time for the next speaker. Okay. I'm Ruoqing from Institute of Software, Chinese Academy of Sciences. And my work is to do the RISC-V virtualization. I'm expanding the software ecosystem of RISC-V. Okay. My topic is towards secure container infrastructure on RISC-V from RustVMM to Kata-Containers. I'll explain this a bit why it needs to start from RustVMM and eventually into Kata-Containers. Okay. And it's more like an update or report of the works we have done and works we planned to be done in next few years of Kata-Containers. And these works are closely related to Kata-Containers, but not necessarily directly went into Kata-Containers. I'll explain this later. So if you happen to be a beginner of Kata-Containers, this talk is here for you to get a whole picture of how Kata-Containers is architected in the Rust creates view. So before we dive into it, I would like to start with the question, why RISC-V? Like several months ago, I was here in Paris. I was attending the RISC-V Europe Summit. That's a marvelous summit. A lot of European RISC-V companies, like IP companies, hardware companies were there, sharing their updates and showing their products. If I have to summarize that summit with a few keywords, the first among them must be sovereignty. We have been hearing these words during this conference as well too. So, to my understanding, if sovereignty is what we are following, then we need sovereignty at different levels. If we are heading to the direction of having sovereignty over cloud infrastructure, then we also need sovereignty on hardware as well. So RISC-V, with its open source nature, is the choice here. RISC-V is inevitable in the sovereignty's view, and RISC-V thus is inevitable for Kata-Containers. Before we dive into it, I'm not a native English speaker, so excuse my language. I apologize first. Okay, back to the topic. I'm going to start with the roadmap we have planned for the next few years. I wish we could finish it ahead of time. I'm catching up the schedule. I'll try my best. Okay, this is the roadmap. Kata-Container is here. Oh, sorry. So from the bottom up, the part I'm in charge of is from the OS. Like the distribution we have chosen here is OpenEuler. Of course, we work with other distributions as well, like Fedora, CentOS, and Debian, and extras. And from the OS level towards the virtualization library level, which is RustVMM, and for the hypervisors, which directly or indirectly depends on it, we have QEMU. Yes, we have QEMU that depends on RustVM. Some of these great, yes. And Dragonball, which is built in for Kata-Containers. It's a VMM library. And Cloud-Hypervisor, I hope some of you have heard of it before. And last is StratoVirt. And surely there are VMMs or something like that, depends on RustVM as well. I did mention here because of, we will eventually try to support them on RISC-V architecture, but just not at this stage. Okay, after we have worked out those hypervisors, these VMMs on RISC-V architecture, we can eventually use Kata-Containers on RISC-V architecture, because Kata-Containers needs virtualization engine to boot VMs for it to work. And at the second stage, the first stage I didn't mention, we are trying to run Kata-Containers, solely run Kata-Containers on RISC-V architecture. So we just choose one hypervisor, which is Cloud-Hypervisor. We are heavily invested in that Cloud-Hypervisor. And the current status of Cloud-Hypervisor is it is capable of direct booting Linux on RISC-V architecture now. And we choose Cloud-Hypervisor as the hypervisor for on RISC-V, and Kata-Containers eventually, for the works we have now, it is working on RISC-V. And the next stage is we trying to expand the ecosystem. We want to provide more hypervisor choices to our end users of Kata-Containers. They can choose QEMU. Of course, it supports RISC-V very well. So that's not that's not what I'm covering now. And for the rest of the hypervisors, I believe some of our end users are using it. That's what we need to do at the second stage. Like, we need to support eventually Dragonball on RISC-V architecture and StratoVirt and libkeyron and something like that as well. Okay, following that roadmap, we have achieved some milestones till now. So my topic mentioned where I'll continue my topic from RustVMM eventually to Kata-Containers. So I will start with works we have done in RustVMM community. Okay, our institute, our team started this work of running hypervisors, trying to run hypervisors on RISC-V architecture beginning from the last year. And back in that time, we were trying to run Cloud-Hypervisor on RISC-V. And I suddenly realized some of the dependencies is not building, simply not built on RISC-V architecture. So I dived a bit. I find the RustVMM crates, and after I have more knowledge of RustVMM community, I suddenly realized it provides the library for a lot of hypervisors, not just Cloud-Hypervisor. So this picture I've drawn is a flat view of how RustVMM community, how its crates are layouted. And I have a picture, I have a talk presented last month on KVM forum, and we are speaking some topics of RustVMM community, and this is a more dependency view of RustVMM community. The RustVMM community consists of like 30 repositories, and they are Rust crates, of course, and they have a very complicated way of eventually building and enabling a VMM. We have having some operational challenges and headaches of bumping the crates and supporting new architectures, but that's not what I'm going to cover here. So the crates I listed here, like KVM bindings, KVM ioctos, and Linux loaders, these are architecture-specific crates. So these crates only support two architectures, namely x86 and ARM, before I went into the community. And fortunately, we have worked out the RISC-V part by now, and RISC-V is now the third officially supported architecture of RustVMM community. While I am conducting the work, I have been questioned by the maintainers of RustVMM community. We don't have the real hardware which is capable of running virtual machines on. I mean, the hardware we get does not have H extension yet. Yes, as of today, it is the situation now, and that's not very accurate. I have heard UltraRISC had making some progresses in vendoring these hardwares. But on the market, most boards we can purchase and we can have, they just do not have H extension. So for the Intel, it's like you do not have a VTX extension, and for the you do not have the hypervisor extension, if I remember correctly. So if you don't have H extension, you will not be able to probe KVM, and you cannot run VM on these hardwares. So the maintainers have been asking me, we don't have these hardwares, how would us build CI for RISC-V code? How would supervise the RISC-V codes in case they get rotten in just a couple of days? Yep. So to work around this, I mean, because we don't have this hardware, and another reason is RustVMM is is open sourced by Amazon Web Services. They are very conservative of us providing hardwares for them. So I eventually come up with this solution. We are running a full emulated, not just one. It depends on how the CI workflow is configured. Ideally, we run the full emulated RISC-V virtual machines by QEMU, and on x86 machines, which I believe it has better performance. And inside that virtual machine, we have choose a dedicated kernel of version like v6.10, and we are trying to bump it because RISC-V is a bit new for the kernel, so a lot of new features went in. We need to catch up, and we eventually boot a virtual machine for the CI to run inside of the RISC-V hardwares. And they are not using, another problem is they are not using GitHub Action Runner, and they are using BuildKit, and I work out BuildKit first, and eventually for the workflows to work on RISC-V on x80 machines provided by Amazon. And after like 3 months of work and negotiating with the maintainers, they finally agreed us to introduce this whole workflow to supervise the RISC-V code in the community. So as of now, many of the crates are supervised, are running the RISC-V CI, so it is kind of guaranteed the code is at least working, and contributions are welcome if you have found any problems. And after we worked out the RustVM crates on RISC-V architecture, we can eventually went to the next step, try to make the hypervisors work on RISC-V architecture. So the first hypervisor we have chosen is Cloud-Hypervisor. It's a Rust-written hypervisor. It is capable of booting Linux and Windows as well on x86 architecture and ARM architecture. Yes, and this is a dependency graph generated by Cargo Graph. I cannot recollect the exact name, but yes, the green crates. Oh, it's a bit. Thank you. Okay, the green crates are from RustVMM, and the blue crates are from Cloud-Hypervisor. We can judge from this picture how Cloud-Hypervisor is closely integrated the RustVM crates. And not to mention, while we are working trying to work it out on RISC-V architecture, because there are a lot of code of MSHV, which is the Windows counterpart of this hypervisor. There are lots of problems, a lot of macros, lots of functions to disable as solely for RISC-V architecture. But eventually, from the bottom up, we are trying to. This is not very clear. I'll try to. Okay, this picture I believe is more understood and visible. Okay, and inside the Cloud-Hypervisor community, we first work out the hypervisor crate, which is the component directly interacts with KVM through the RustVM library, and onwards that we worked out the VM allocator on RISC-V. Namely how the memory are managed on RISC-V architecture, and how the GSI, how the interrupt numbers are handled on RISC-V architecture. And these crates are not very like the virtual devices and devices crate, except for the RISC-V AIA, which is the, if I take ARM for example, it's the GICV3. Interrupt controller for RISC-V, I believe. Okay, these are not very architecture specific, but eventually we have managed to work out based on the works we have done in RustVM community, and Cloud-Hypervisor now builds and works on RISC-V, and we inside the Cloud-Hypervisor community we have CIs to run RISC-V. Some RISC-V build jobs and some of the test jobs as of a very low-level crates. Like, yes, while I was doing this work in Cloud-Hypervisor community, I was questioned again. Like, we do not have hardwares. How are we going to do the tests for the RISC-V code? Because RustVMM is relatively small libraries, so if you run those codes, run the cargo test commands on inside the full emulated VMs, it's acceptable. Like it takes 5 minutes or 10 minutes to finish. But when we come to the hypervisor level, it is more gigantic compared to the RustVMM. So. Because the integration test for x86, it takes like 2 hours to complete. I just can't imagine how much time it will take on RISC-V, especially when the RISC-V hardware is emulated. So I talked to the maintainers in Cloud-Hypervisor community. I'm glad some of them are moved to RISC-V companies like in Revos, so they are very open and they are very open to RISC-V architecture. So this work does not have much problem, and they are accepting our machines. And unfortunately, we do not have those RISC-V hardware. So as of now, we are providing x86 machines to them, and those machines run solely for emulated RISC-V VM to listen for the jobs, for the RISC-V jobs to run for each pull request the contributors have raised. And after this work is launched, and some of the RISC-V PRs are approved and merged in the community, Cloud-Hypervisor V46 now is capable of direct booting RISC-V Linux now. And we are still trying to addressing some feature gaps between the RISC-V architecture and x86 and ARM. Oh, sorry, the version which supports RISC-V is V45, okay. And this is the, so namely we have achieved, in my words, it would be, we have achieved the stage 1 of RISC-V support in Cloud-Hypervisor community, and we are now moving on to the second stage, like the features I listed here. We are trying to enable TPM devices, enable PMU and UEFI related stuff like ACPI feature, hot device plugging, hot plugging, that kind of thing. Yep. This is what I've been doing this couple of months. So I need to confess I haven't put too much time into Kata-Containers community recently because of I'm trying to work out a Rust hypervisor for Kata-Containers. Okay. So there is another feature I was very interested, but it is very long before it can address eventually can be landed on RISC-V architecture. It is the because Cloud-Hypervisor boots Windows on Linux. It's a marvelous feature, and we have this screenshot from one of the contributors of Cloud-Hypervisor that shows he's booting the Windows guests on Linux host. And I hope this eventually, I would see the day that RISC-V supports Windows supports RISC-V, and we can do this work afterwards. Okay, now we are at Kata-Containers. We have a working Rust hypervisor here, which is Cloud-Hypervisor, which directly boots RISC-V virtual machines. And this picture is just to my topic, which explains why from RustVMM to Kata-Containers. This is what you get when Kata-Containers actually run. Kata-Containers itself does not just comprise of the runtime, two versions of runtime. We have an agent, we have it. The virtualization engine is part of it. So when you run Kata-Containers, you actually run this software stack. I mean, not necessarily Cloud-Hypervisor, maybe other hypervisor choices you have made, you're using, that's okay. And since we have a working Rust hypervisor, we can try to verify the correctness of the works we have done in Kata-Containers. We can build and run the tests. Okay, and as of now, we have worked out the they presented in this picture from the OS level onwards. We have a full Rust-based software stack, and we managed to launch the RISC-V support to the 3.7 release of Kata-Containers. We just a part of it, as I need to. So the components we supported is Go runtime with QEMU. Yes, we just tested QEMU as of now, and Rust runtime with Cloud-Hypervisor. Yes, not with QEMU yet. And agent, of course, agent itself is not very architecture specific, so there hasn't been a lot of work in agent. Okay, so. Again, when I come to Kata-Containers community, I was questioned by the maintainers, by the AC members. We don't have the infrastructure, we don't have the hardwares of running these tests. And I know, because I was contributing to Kata-Containers community like 3 years ago. I know when I was a student, I raised a PR, and the full CI needs like 2 hours or 3 hours complete, and I just can't imagine how long it would take to run the full set of tests on RISC-V architecture. So I proposed this several times, and eventually they agreed we can just do the build test for RISC-V architecture as of now, and I will be responsible of looking after them. And we are because the components inside Kata-Containers is relatively big than the previous softwares. So we are trying to we are providing the real RISC-V hardwares like SG2042, which is the RISC-V hardware we can get with most cores, which is most performance we have. This hardware has like 64 cores, so it can finish the build process like within half an hour, which is really acceptable. I tried to build the Go runtime or Rust runtime in full emulated RISC-V environment. On x86, it's like 40 minutes to an hour. I'm not sure. And so after the CI machines was connected to the community, and we set up the pipelines for RISC-V part, and we eventually landed this code, the RISC-V part of Kata-Containers, into the community. But there are still a lot of work to be done because, like I mentioned, the Cloud-Hypervisor and the Dragonball hypervisor, they are not, the feature gaps are not addressed. So I'll need to address those feature gaps for the runtimes. We have 2 versions of runtime to correctly coordinate the commands, the interact with the hypervisor, with the virtualization engine. Yep. So this is the current status of Kata-Containers on RISC-V architecture. And I have a little demo of it demonstrating the whole work. Like I said, our institute have chosen the Open Euler distribution, which has started trying to start RISC-V architecture support years ago. So we are working with them. This picture is showing I'm launching a very old Kata-Containers in Open Euler distribution. They are still using v3.13 of Kata-Containers. I backported their RISC-V code to their version, and eventually I'm running Kata-Containers with QEMU as its virtualization engine on a RISC-V emulated machine. And here is a live is a video I recorded. The left terminal is left and right terminal connected to the same RISC-V machine, the RISC-V virtual machine, and at the left terminal where I'm starting the container at the foreground, and at the right we can see the instruction set of the host machine. It has a lot of instructions supported, and I'm using CTR to boot a container. Okay, you can see yes, it takes really long to boot a container. As of it needs to boot a VM first. And at the left side, we are receiving logs from QEMU, and it is trying to boot the VM. Yes, it really takes several seconds. Okay, now we are into the container, and we can see inside the container, we have a different set of instruction sets, which is supported by the virtual machine. Yes, it is designed to be different. We cannot just export every instruction from the host to the guest, and which shows we are actually at different environment, and showing that the whole stack is working because the container we are running, we're running inside a Ubuntu guest, and we can see, yes, this is a RISC-V container. Yep. That's the gist of the demo, and we are still like at the end of the year. We believe we can have the real we will eventually have real RISC-V hardware, which is capable of running KVM, and it has a correct interrupt controller, which is RISC-V AIA or ARM GICV3, that counterpart, which eventually works with Kata-Containers. So I will try to get hold of them and connect to the community, and we can thus with them, with those infrastructure ready, we can onboard more integration tests, more unit tests for RISC-V architecture, which would function more efficient. As of now, the RISC-V part of our CI is constantly broken because those machines are not very reliable, I have to admit. And I hope those hardwares we are going to get hold of would be better than those we were having, and so hopefully, I believe we can eventually land and announce RISC-V support for Kata-Containers at the end of next year. I will try my best to achieve that goal. So this is all of my topic, and we have a lot of Kata-Containers topic afterwards. If you are interested in them, please be there. We have a lot of maintainers, dedicated maintainers and AC members presenting those topics. And if you're interested, just please go there. Thank you. If you have any questions, you can find me outside or any way you like. Thank you.